Good morning students, welcome to our next lecture of data structures and algorithms. In our previous lecture we studied about linked list operations. In that we studied two different operations. First one was creation of linked list and the second one was traversing or display a linked list. Continuing the operations of linked list, we will study two more operations. Third one is insertion in linked list, that how we can insert in a linked list, and the deletion in linked list, that how we can delete a node from a linked list. We will study these two operations today. So starting with insertion in linked list, we are taking a node in linked list that contains data. We are taking a node in linked list, that means a node. We are taking a node in a linked list that contains data. First part contains data, and the next part of this node, the next field contains next. So the first part data will contain the data element of that node, and the next field of this node will always contain the address of the next node in the linked list. So this is the node we are taking in a linked list that contains data, and another field next pointer that will always point to the next node in the linked list. The pointer start will always point the first node. The start pointer will always point to the first node. So starting with the steps, first step is begin. We will begin the insertion in linked list. For insertion, we will declare struct node star q. So before inserting in linked list, what we will do, we will declare node as struct using star q. After that, we will set the value of start as assign memory address using malloc function. After declaring the struct node star q, we will set the memory address using malloc function by the statement start is equals to assign. Okay, we will assign the memory address using malloc function to that starting node. After that, in step 4, we will set q implies data is equals to num. That means the node that we have taken, we are denoting it using q. So we will insert the num, that means data, in data field of the q node. So we will insert num in the data field of the q node, this node. After that, we will set the value of q implies next equals to start. That means the next field of this q node, we will assign the value of the next as start. After that, we will set the value of start as q and return back to the previous state. In this way, we can insert a node in a linked list using these following functions. And in second operation, that means deletion in linked list, that means if we want to delete a node from a linked list, what operations we will follow? We will begin our algorithm, then we will start with declaring the struct node star q and star t. We will declare the node using the struct keyword by star q and star t. After that, we will set the value of q is equals to start. Okay, we will set the value of q equals to start. Now step 4 states that if q is equals to null, that means if the value of q becomes null, then the system will show the output as list is empty and our program will return back to home. Okay, if the value of q becomes null, the system will show us the output as list is empty and return back to the home. And in step 5, if q implies data is equals to num, that means if q is not null, If q is not null, that means q contains some data. If q implies data is equals to num, that means if q contains some data, then we will set start is equals to q implies next. We will set the value of start as q implies next, that means the next field of the q node. After that, our system will show us the output as element removed, that means the start pointer will contain the value of q next, and that q node will get removed, and after removing that q node, our q will become free and our program will return back to home. After that, after removing that node, what we will do, we will set t is equals to q, that means we will move towards the next node that we want to delete, and we will set the value of t, that new node, to be deleted by q, and then we will assign the value to q as q implies next, that means the next field of the q. After that, we will repeat step 8 until q becomes not null. So we will repeat this step 8 till q is equals to not null. Step 8 states that if q implies data is equals to num, that means if q node contains data as num, then we will set the value of t implies next equals to q implies next, and our item or data element will get removed, and the value of q will get free, and our program will return back to home. Else, if q implies data is not num, then we will set the value of t equals to q and q is equals to q implies next, and then our program will show us the output item is not found, that means no data element is found that we can delete, and our program will return back to home. So in this way we can delete in linked list. Again summarizing, in insertion in linked list, we are taking a node. In that node, our first field is data, which contains the data element, and the second field is next, which contains the address of the next node. So the start pointer will always point to the first node. For insertion, we will declare the node using struct keyword as star q. We will set the value of start equals to assign, and we will assign the memory address to the start pointer using malloc function. After that, we will set the value of q implies data is equals to num, that means we will insert some data element in the data field of the q node, and q implies next, the next field of the q node will contain the value start, and then start will be equal to q, and our program will return back to home. So in this way we can insert in linked list. And in deletion in linked list, we will declare the node using struct star q and star t. After that, we will set the value of q equals to start. After setting the value of q equals to start, we are having two conditions. If q is equals to null, if the value of q becomes null, then our program, our system will show us the output list is empty and will return back to home. If q is not null, that means if data field of q node contains some data, that means num, we will set the value of start is equals to q implies next and write the element removed, and then our node q will become free and our program will return back to home. In step 6, we will set the value of t equals to q, that means when we want to remove or delete another node after q, we will set the value of t is equals to q and q is equals to q implies next. Then we will repeat step 8 until q does not becomes not equals to null. Step 8 states that if q implies data contains num, that means if data field of q node contains the value num, then we will set the value of q next equals to q next. After that, we will write the message element removed, then our q node will become free and program will return back to home. But if q data does not contain num, then we will set the value of q, t is equals to q, and q is equals to q implies next, and output will be shown as item is not found, that means no element is found, that is to be deleted, and our program will return back to home. So this was all about different operations of linked list. I hope you all have understood. Thank you very much.